Hello everyone, welcome back to another Stat385 video. So we are going to continue discussing some sort of just like just kind of wrapping up on things that you can do in the tidyverse. And in this video, we'll in particular discuss dates and times. So it's, what's the way to say this? It is not exactly a very easy topic. We're not going to go into all of the details here. This is something that, in my experience, comes up relatively infrequently. I'm not the best at using this Lubra date package that we will discuss. I have the cheat sheet up. The cheat sheet will be referenced on the course webpage. It's not something that comes up that often, and the functions that I have used in it, namely some of the ones on this first column right here for parsing date times, I found to be relatively easy to use and to be game changers. So it is important. So this Uber date package is important when it comes up. Just dates and times don't come up that often. Okay, so I'm in my Stat385 directory. I'm going to first call library tidyverse, and I can see LubraDate is a part of the tidyverse. I don't know if it was always the case that it wasn't in there, but it is now in there. Okay, so that's good. Okay, so first of all, let's talk about date time. Okay, so I'm going to just specify a large, I'm just going to go all the way. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So I'm going to input a double, right? And it comes back with this. So you may be looking at this and just saying, what is happening here? So essentially, it took this 123,456,789 and converted it to this particular date, 1973, November 29th, time in UTC. UTC is some sort of standardized time code. Yeah, so time is very hard, right? Like there's different time zones. There's daylight savings time in this country. Other countries have different rules. I think that it's just a really tricky concept. So this UTC is kind of the standardized reference point for time. Okay, so then we have hours, minutes, seconds. So what is this in reference to? Date time, 1. I put in 0? Okay, so essentially January 1st, 1970 is the initial reference time for this. And this has to do with some sort of Unix history. I'm not an expert on it. I just want to see if I can do this. Oh, okay. So 0 is January 1st, 1970. That's the reference time, and we can go back in time and specify negative numbers. So we talked about factors earlier being corresponding to integers. Dates correspond to double in much sort of, I guess, the same way, or not exactly the same way, but like doubles correspond to dates, integers correspond to factors, even though it's relatively unintuitive why that would be the case. Okay, so let's demonstrate. Okay, let's do. So over here we have this in this LubraDate cheat sheet. We have this parse date times. And what this column is doing is it's presenting a variety of commands for how to convert a string or set of numbers into date times, or so things to be understood as dates. And so here you could see something like, if I had the input this thing, then if I specified the year, month, date, hours, minutes, seconds command, then it would convert it into an actual date. Okay, so a very simple version of that, oh yeah, it's right here, this YMD or YDM. You know, it depends on how it was inputted. Okay, so if I have, say, the character string 2023 1023, then is this a date? Well, no, because it's a character, right? Right. So what I could do is use year, month, day, and this will convert the string into a date, 2023 1023, and boom, true, it is a date. Okay. Likewise, you know, you do have to be awake when you use these, because you could do this as well. Now I think this will complain, right? Because I put day before month, and here it would be 10th day of the 23rd month. So that's no good. Okay, and what happens if I do this? So this is a standard output for a day: year, then month, and then day. Yeah, I think the reason for that is that it makes it so it makes it into a sortable form. Okay, so, and then there's all kinds of MDY, MYD, YMD, YDM, all these things, all the different combinations that you could represent a character string to correspond to a date. If you provide the right YDM or YMD or month D, MDY, then you can convert it to a date, and it would output as in the convenient standardized form, so that the dates can themselves be sortable in an intuitive way. Okay, so this is, to be honest, this is the one, this YMD is the one that I've used probably the most, the thing that comes up the most in practice. Okay, so let's see here. There's also a command in this that just gets the current time, 2023 1023, and so you can actually see, well, with respect to, oh, this actually has Central Delta time on my computer, so you can see exactly when I'm recording this lecture. I'm recording it at least a week before you're watching it. It looks like. Okay, so anyways, so that's cool, and I'll use this. I'll wrap up with something cool at the end that makes use of this now function. Okay, so where this parse data, okay, let's see, this parse dates time thing gets very useful. Where is it on the cheat sheet? Oh, right here, parse date time. So I could have something, I've seen this before in data, not too often, but somebody will input something in like an Excel sheet that you'll load in, and it will say something like Monday, October 23rd, and then maybe provide some sort of, we'll just take the time that I had, 14-hour 3525, and then the year. Okay, so it's a character, right? Is that character? Okay, let's call this, okay, actually, let's just leave it. Okay, so I can use a more general, these are sort of like automatic parse date times things when things are written in convenient forms that are basically close to something that you would represent as a date in R. This one, as you can see that it has information as a date. We can read it, we can see it, but like R has no idea what's going on. So we have to use a more general parser to make this useful. Okay, and that's where this parse date time comes in. Parse date time. Okay, I'm gonna read the documentation. Parse date time. Okay. So user-friendly date time, well, that's subjective, user-friendly, but I guess. So we have our thing that we want to coerce to a date, and I'm just going to go, okay, so the list below contains formats recognized by LubriDate. A full weekday name in the current locale. So that looks like, is it given in, okay, so it's given in orders, the orders argument. Okay, equals, so we have a day name, abbreviated weekday, so A. We have a abbreviated or full month name, so we're using October, oct abbreviated, B. Okay, and then we have a day of the month, decimal or number, or as decimal number. Okay, I think that'll work. D, and then we have in a convenient form, hours. Okay, H, and then we have a colon, quarter, no, month. Okay, month, no, minute. Yeah, minute. M, and we don't have AM, PM, second. Okay. And then we have a space, week, year. Year without century. No, we have year with century. Okay. Oh my goodness. Okay. It worked. But it converted it, just keep in mind that it converted it to the standardized code, the UTC, and not the Central Delta time. Okay, so this took in input Monday, October 23rd, 2:35:25 p.m. 2023, and converted it into the relevant date. So this thing is fairly nice because, you know, it's just going to look for any abbreviation to these things. So, oops, that worked. Okay, so I guess it has to be pretty standard abbreviations. Okay, anyways, I can mix the capitalizations, which is something that's cool because usually R doesn't do that. Let's see, can I, and if somebody types this, that would be, okay. All right, don't do this, but it's cool that this parser actually works. Okay, so I haven't had to use this too often, this parse date time. I've mostly had to use this column, but it's good to know that this parse date time function exists. Okay, so as we've done so far in the past, we're not going to go through everything on this cheat sheet. I'm going to cover just some of the more important stuff, and I think this would be relatively short video. Let's see. Okay, so I'm going to take this thing and call it some date. Okay. So let's see it. Oops. Okay, so we have our date. I can ask, is it in the morning? Is it AM? No. Is it PM? Yes. Okay. So that could come in handy. I haven't personally used it, but that's kind of nice. One thing that you may use is doing math on top of date times. Okay, so some date, let's do some date plus 1 just to see what happens. So this plus 1 just added 1 second. Let's say if I add 60 seconds. I'll just keep it here. Okay, so that added 60 seconds, which is a full minute. Okay, cool. And I can take the date and obtain the corresponding double. So you can see here that how this addition actually works under the hood. So a date corresponds to a double. The double references seconds since the reference date, which is this January 1st, 1970, in this, what's the time zone? UTC time, the standardized time zone to work with. Okay, so, right, so we have type of, some date is double. Okay. Okay, so just like I added individual numbers, which correspond to seconds, I can add different units of time. So I could take some date and add months, 3. Is it months? Yeah, it's with the S. Keep in mind that you have to have, it can't be month, it has to be months, and then that will add 3 months to the date. You can see what happened. Went from October to November, December, January. Next year, iterated out. Cool. And I can chain these together. I could do something like years, 5, months, hours, 5 plus 17. And that's seconds. Let's just see. Some date. Okay, what happened here? I added 5 years, that got me to 2028. I added 3 months, that took me from October to January 2029. I added 5 hours, that took me from 14 to 19, and I added 17 seconds. So you can see how this works. I could also do all of this as well. Okay, cool. All right, so that's basically it. I do want to work at something a little bit more complicated just to go through something with some filtering. So I'm going to take now again. Now has changed because we're further along in time. And so I'm going to store this ref. Okay, so I'm going to create time df equals tibble time equals, okay, bear with me now because I'm going to put this on a new line. S apply 20,000 to 20,000 function x ref, which is that date, minus x. So I'm going to subtract all of the seconds from 1 to 20,000 from my date. Okay. Now what does this look like? So I skipped ahead. I wanted to do sapply and have it guess at the format to convert it to. However, I think that's pretty hard for it because date is a pretty non-standard format. So I think it just converted it all to double. So if I did lapply, I get the actual dates. Okay. Now what happens if I unlist it? Nope, didn't work. Okay, why didn't that work? Okay, well, I think I have another trick. Okay, I don't think I've done this too often in this class, but I can take a list and I can collapse the elements on top of each other. Hopefully this is type preserving. Oh, you know what? Actually, here. Better yet, let's go back. Okay, and then let's do as date time, vectorize it. Bingo, there we go. That's what I want. Oh, could I just do that right on sapply? Yeah, let's try that. As date time Okay, good. Now I have time. Now I have a tibble with a time variable, and you can see that it's essentially -1 second from the reference, -2 seconds, -3 seconds, and so on. So now I could do something like time df filter. I want all times greater than equal to ref -200. This is obviously kind of trivial, but because it's just going to pull a tibble of size 200 the way that everything is defined. But you can see how this could come in handy in a more realistic application. In fact, I've used it before. If you have a date, if you have a date column and you want all of the entries greater than some date and time, you can just do filtering as before, provided the reference is in date form. Okay, because this has a nice ordering to it, because it's going start with year, month, day, hour, minute, seconds, and ordering it that way makes it really easy to do the filtering or express dates as larger or smaller than each other. So, okay, so this is a relatively short video by our standards so far, but this is a good introduction into LubriDate. I didn't cover anything on, or everything on this cheat sheet, but you can see, so if you need more, here it is on the cheat sheet, and then there's more stuff in the actual LubriDate package, which is consistent with all the things that we've talked about so far. Mostly keeping in mind these YMD type commands for parsing date time is going to be the thing that you'll probably use the most. At least that's the thing that I use the most. More general parsing exists for like really bad Excel entries that you would import in, and then of course some filtering type stuff. That's what I've come to find that I've used in practice before. So it's cool that R has this. You know, we've covered a lot of different types of vectors and objects in R, and last video we talked about factors again in more detail, and now we have dates. So you could imagine a tibble or data frame with doubles, integers, maybe some logicals in the mix, dates, and factors. I'm trying to think. Yeah, I've used a data set that has had a lot of numeric variables or doubles, a lot of factors, like more than one, and a date. That comes up quite a bit. So yeah, there's a lot of things that you can use in data analysis. So you get a structure like this with multiple types, and then you have to do some work on it for wrangling it and then feeding it into some sort of regression model or statistical procedure for analysis after doing some visualizations to see what you're doing, which is an important step, and I should have emphasized it a little bit more. Okay, so yeah, we're at the end. I'm starting to ramble. Thank you for your attention, and I will see you next time. All right, take care. Bye.